Hello everyone. Now today let's look at how to solve this thermal physics question. Okay, so we have the volume of a fixed mass of an ideal gas is V. Okay, the gas exerts pressure P and has thermodynamic temperature T. The temperature of the gas is now increased to 2T. That means the temperature becomes doubled. Okay, the new pressure exerted by the what by the gas is 3p. That means the pressure is what tripled. All right, so what is the new volume of the gas in terms of V? Yeah, we know that ideal gas, okay, is the gas that obeys Boyle's law and Charles' law. Yeah, because we know that Boyle's law, okay, states that the volume of a fixed mass of a gas is inversely proportional to its pressure, provided that the temperature remains constant. That means when the temperature is fixed, okay, the volume will be what? Will be related to what? Pressure. That is, the larger the volume, okay, the larger the volume, then the what? The lower the pressure, okay, and then the smaller the volume, then the what? The higher the pressure. That's in the case of Boyle's law. Now, in the case of Charles' law, we have that the volume of a fixed mass of a gas is proportional to its absolute temperature. Absolute temperature is what we have here as thermodynamic temperature, also known as Kelvin scale temperature. And the unit of T in this case will be considered to be what? Kelvin, not Celsius. All right, so provided that the pressure remains constant. So that's in the case of Charles' law. So when both laws are combined, then we are going to have an equation. We are going to have an equation known as the ideal gas equation. All right. So what I'm saying in essence is that now we know that Boyle's law, according to Boyle's law, okay, according to Boyle's law, we have Boyle's law to be V proportional to, okay, V proportional to 1 over P, where P is the pressure, okay, and V is the what? Volume. Then also for Charles' law, okay, Charles' law states that V is proportional to what? Absolute temperature. Okay. So when these two are combined using what we call joint variation in mathematics, okay. Now by combining this, okay, by combining this, okay, when we combine these two, we're going to have V is proportional to T over what? Over P. Okay. Now, when we replace the proportionality sign, okay, with equality sign, then we are going to have a constant. Okay. That means a constant will be what? Inserted. All right. So in this case, by inserting a constant, after which we what? We replace the proportionality sign with equality sign. Okay. Let's say the constant is K. So we have KT over what? Over P. Okay, over P. So when we cross multiply, we're going to have PV equals to KT. So let's express K in terms of PV and T. So we have PV over T. And this is what now the K now the K now stands for what we call there's what we call the ideal gas constant. Okay, the ideal gas constant from the ideal gas equation. So this is our ideal gas equation. So we can replace K with NR. Okay, that is for n mole of a gas. Okay, for n mole. Okay, for n mole of a gas. Okay, then we have NR equals to PV over what? T, which is same thing as what? NRT equals to PV. Okay, now for 1 mole, okay, for 1 mole of a gas, okay, for 1 mole of a gas, then it will be R equals to PV over T, and that will be what? PV equals to RT. So this is just for us to understand what it means when we talk about the ideal gas equation. Now let's get into the solution. All right, so here we have the volume of a fixed mass of an ideal gas is V. So which means the original volume, okay, the original volume, okay, let's say that we have in the initial state, okay, in the initial state, we have the original volume. Let's say the original volume is V. Okay, the original volume is V. The gas exerts pressure P, okay, and has thermodynamic temperature T. So that means the original pressure Okay, the original pressure will be what? P. And then also the starting temperature. The starting temperature, also known as the first temperature, that will be what? That will be T, or the original temperature. All right, so now, so because the gas, okay, the gas is an ideal gas, so we're going to write the equation for an ideal gas, okay, which is what we have here as nRT equals to PV. So which means in the initial state, we're going to have nR, okay, nRT equals to PV. Okay, so let's say this is the first equation. This is the first equation. Remember, we want to write the new volume in terms of V, which is the what? The original volume, okay, or there's the first volume of the gas. All right, before it's now, before it now, before the volume, before the pressure now what become tripled, and before the temperature also what becomes doubled. All right, so we have here that the new, okay, the temperature of the gas is now increased to what? 2T. The temperature of the gas is now increased to 2T. Now, let's say in the final state, now the final temperature, okay, the final temperature is 2T. Okay, now the final pressure, okay, the final pressure is what? Is 3P. That is, the final temperature is 2 multiplied by the initial temperature, or the temperature in the initial state. Then the final pressure is what? Is equals to 3 multiplied by the pressure in the what? Initial state as well. Remember, TF, okay, represents the final temperature. That is the final thermodynamic temperature. Okay, PF, okay, represents the final pressure. Okay, the final pressure. So now let's write the equation, the ideal gas equation for final state. Now, in the final state, now we know that nRT is equal to what? Is equals to PV. So P, okay, P final, okay, remember we have V final, because here we have the new volume, okay. We can also use new volume, okay, where Vn, okay, Vn represents the new volume. That's a new volume. Now we know that the temperature, which is the final temperature, okay, when we have a new volume, we have the final temperature. So in this case, now we're going to write, now what is the final temperature? The final temperature is 2T. Okay, so this is the second equation. This is equation 2. Okay, so we are going to represent final temperature with what? 2T. So we have nR multiplied by 2T. Then PF, which is the final volume, final pressure, that will be 3P, okay, multiplied by the new volume. Multiplied by the new volume. Okay. Now, because now we know that nR, can you see nR equals to PV over T. Now, equation 1, from equation 1, we know that nRT is equals to what? PV. Okay, so which means that to get the equation for nR, we're going to write nR to be equals to PV over what? Over T. So which means we're going to replace nR with what? PV over what? Over T in this equation. Remember, we must express the new volume in terms of what? In terms of V. All right, so in this case, we're going to what? We're going to, which means this nR will now become PV, okay, this equation. So we have PV over T multiplied by 2T equals to 3P, okay, then multiplied by the what? The new volume, okay, the new volume. All right, so we want to find out the what? The new volume. So in this case, we have the what? The initial temperature. Am I right? So I'm going to what? I'm going to divide. So we can now divide this equation by what? By 3P. So when we divide this equation by 3P, so we're going to have PV over T multiplied by 2T, then divided by what? 3P. And this is equals to 3P, then the new volume divided by what? 3P. Okay. So in this case, this will cancel out. Okay, we can also write this way. We can write it this way: 3p Vn over 3p. Okay, so that we have the new volume to be equals to. So in this case, we are going to have PV multiplied by 2t over what? T, then times 1 over 3p, times 1 over 3p. Now p will cancel out, then t will also what? Cancel out. So in this case, we now have v times 2 times 1. That will be 2v. So the new volume will be 2v over what? Over 3. So this is the new volume of the gas in terms of what? In terms of V. Remember, I said in the initial state, the original volume is what? V. Then the original pressure is what? P. And the original temperature is what? T. So when we write the equation, that's the ideal gas equation, we're going to have nRT equals to what? PV, where R represents the what? The molar gas constant, or the ideal gas constant. Okay, so that's for the initial state. Now for the final state, that's why I use TF. The temperature is doubled. That is, the final temperature is twice the what? The initial temperature. Okay, and the pressure, the final pressure is what? Is 3 times the what? The original pressure. So we have 2T and then we have 3P. So, and I said here that TF represents the what? The final temperature, and then PF represent the what? The final pressure. So which we have the equation here as nRTF equals to what? Equals to PVN. Okay, equals to PVN. All right. So we have equation 2. So this is our equation 2. This is our equation 2. And I said here that this is the new volume. Vn represent the new volume. So then we also recall from here that Nr is what? Is PV over what? Over T. And then when we divide both sides by 3P, then we can now have our Vn. So Vn is the new volume, okay, which is equals to 2/3, that's 2 over 3 times the original volume. The noblest pleasure is the joy of understanding. Bye bye.